Edexcel Further Maths, Complex Numbers 1, an Introduction to Complex Numbers. In this third session we're going to be looking at multiplying complex numbers together. So a reminder about the distribution law for multiplication. We're going to expand the brackets of the following expressions. So here we'd have 2 times 4, we'd have 3x times 4, we'd have 2 times minus x, and 3x times minus x. And if we collect like terms, we get 8 plus 10x minus 3x squared. Likewise, we can expand the brackets containing the imaginary number I, which of course is the square root of minus 1. So in a similar fashion, we get 2 4s are 8. We get 3i times 4 is 12i. 2 times minus I is minus 2i. And 3i times minus I is minus 3i squared. Before we collect like terms, we have to be careful here. We've got 8 plus 12i minus 2i minus 3 times, and I squared, remember, you've got to be careful with that one, is minus 1. So we've got 8 plus 3 is 11, and when we collect the 12i and the minus 2i, we of course get 10i. I squared will occur many times in your working, and you must take great care to remember that I squared is of course minus 1. Likewise, you will often come across I cubed, which is I squared times another I, so that's minus I, and I to the power 4, which is 1. And the thing to remember here is that I is a surd and satisfies all the laws of surds. So multiplying complex numbers together, we're going to expand the brackets of the following expressions. So here we've got 2 3s are 6, 3 times I is 3i, 2 times minus 4i is minus 8i, and I times minus 4i is minus 4 times I squared, which is minus 1. So we get 6 plus 3i minus 8i plus 4, and collecting real parts together, we get 10. 3i take away 8i is minus 5i. If we're doing 2 plus I cubed, we have to be extra careful here because it's 2 plus I times 2 plus I times a third 2 plus I. Don't attempt to expand all three at once, so I'm going to just do the first two brackets together. So we've got 2 times 2 is 4, we've got 2 times I, we've got another 2 times I, and we've got I squared, which is minus 1. And before I multiply by the third bracket, I'm just going to collect terms together. So there's a real 4 minus 1 is 3, and the imaginary 2i plus 2i is 4i. And then we're ready to do the final multiplication. There's 2 times 3 is 6, 4i times 2 is 8i, 3 times I is 3i, and 4i squared is 4 times minus 1, which is minus 4. And collecting the real and imaginary parts together, the real parts give 2 and the imaginary parts give 11i. Don't attempt to expand more than 3 brackets at a time unless you're going to apply a binomial expansion. So here's an exam style question. We're given z is 2 minus I root 3, and we're going to use algebra to express z plus z squared in the form a plus bi root 3, where a and b are integers. This is a 3-mark question. So the first thing I would do would be perhaps separately to do z squared. So z squared is 2 minus I root 3 times 2 minus I root 3. So that's 2 2's are 4. We've got minus I root 3 times 2 is minus 2 root 3I. Another 2 times minus I root 3 is minus 2 root 3I. And then I've got root 3 times I squared. So that's plus 3 times I squared, and I squared is minus 1. So that came from minus root 3I times minus root 3I. Just tidying it up a little bit, we've got 4 minus 4 root 3I minus 3. So collecting the real parts together is 1 minus 4 root 3I. So now we're in a position to do the whole problem, which is z plus z squared. So z is 2 minus root 3I, and we're adding on z squared, which is 4 minus root 3I. So writing it without the brackets, 2 minus root 3I plus 1 minus 4 root 3I. And if I collect terms together, the real parts, the 2 and the 1 make 3. Minus root 3I minus 4 root 3I is minus 5 root 3I. And there's our answer. The exact position of I in that multiplication isn't vital. Normally I would put I at the end of each term. So in the next session we're going to be looking at dividing complex numbers.